Good morning. Are we having enough quorum to start?
Good morning, sir.
Thiru Srinivasan.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning, sir.
Yeah.
Good morning, Professor.
Good morning, sir.
Yeah, thank you. Thank you. Should I give a few more minutes? Let me just see how many people we have. Yeah, 1, 2, 3, 4, 5, 6. But 13. I think we were expecting 24, right? That's the cohort size. I'll give it a couple more minutes. Seems to always work with this is the 8th cohort we are doing, and then we'll get started. I'll start a little slow so that others can catch up, and then we will go to normal speed. Maybe let me take this opportunity to get your introductions, and I will introduce myself after the 2 minutes. Can I start with EV1? If you know your EV code, yes. Go ahead, please. You're on mute.
Sorry, my bad. Good morning, Mr. Professor Thiru. My name is Lakshdeep Kaul. I'm presently working with Sun Mobility in sales for heavy electric vehicles. We are coming up with the battery swap solutions for trucks and
Yes.
buses. And before that, I worked around 2 decades in automobile only. I worked with Daimler Bharat Benz, I worked with Tata Motors, and I worked with Mahindra and Mahindra also, automotive division. And I did my engineering and then my MBA from IIM Lucknow. So recently I moved from ICE after 2 decades of experience to electric mobility. So I'm looking forward to learn a lot from IIT Madras and especially from you.
Yes. Yes. I think I have EV5 next. Thank you so much. Yes. Yes.
Good morning, sir.
Good morning.
Yeah, myself Karthiban. I'm from Royal Enfield. So I have a overall 18 years experience. So the last 8 years I'm with Royal Enfield. Earlier I was in Daimler. Okay, the complete 18 years I'll be in automobile field. So majorly in structural parts development. So recently I moved to EV. Last 2 years I'm working with the EV team.
Yes.
So this is about a small background about us.
What do you focus on the EV?
EV currently I'm taking care of the structural parts development, sorry, chassis parts majorly.
Yes.
Okay, then slowly we are concentrating on technology and new model coordination also. It is under progress.
Yeah, thank you, and hope you enjoy the course. All the very best.
Sure. So I'm from the mechanical background, so we
Yeah.
have started slowly learning about the electronics and technologies.
Yes. Yes. Me too. I started as a mechanical engineer. EV6, please.
Good morning, sir.
Good morning.
This is Ashwath from HL Mando. I have been in Mando for the past 4 years in the quality department, and previously I worked in TAG Corporation for 3 years, so total 7 years experience. I did my degree in mechanical engineering and ME in green manufacturing. So
Wow.
and we are in Mando slowly the play of components like motor calipers and IDB. So I hope this. I am looking forward to learn a lot from this cohort, and thank you, sir.
Thank you so much. Very welcome. Mr. EV9, I'm sorry I have to use these codes until I learn you. Yes.
Yeah, sir. EV9 myself. Yes, Mr.
Yes.
Ganesh Pandian. I'm from EV from Royal Enfield EV sourcing. I'm
Yes.
handling structural parts development. Last
Oh,
10
okay.
years, I'm developing the aluminum structural parts development. Now this new technology and we are trying to learn.
Yes. Yes. Good challenge. Good challenge. All the best, and I hope
Yes,
you will gain much from this course.
yes, yes.
And then let me jump on to Mr. EV10. Good
Hi
morning.
sir, good morning. This is
Yes.
Selvaraja from Royal Enfield EV sourcing. So I have
Yes.
overall experience of 13 plus years, and in with Royal Enfield I am associated with last 3.5 years.
Mm-hmm.
And here I am taking care of the mechanical proprietary sourcing and developments.
Oh, man,
And
fantastic.
earlier I was
Fantastic.
associated with Lease Electric Mobility.
Uh-huh.
So there I was taking care of all the chassis parts developments.
Very nice. Very nice. I think I will keep this in mind as I walk through the this module. Um, Next, EV11, please. So I think EV11 is not responding. Maybe EV12, you have been keeping your mic open. Yes.
Yeah, sorry, I'm
Sir,
audible.
Okay, okay. EV11, go ahead first. Sorry, EV12. Yes.
Yeah,
Good,
sorry.
Go
good
ahead.
morning, sir.
Yes, good morning.
Sir, my name is Irfan Rasul Mir. I am from Srinagar, Kashmir. I,
Oh,
I
welcome.
hold MTech in Industrial Tribology and Maintenance Management. I am presently
Hmm.
working in Geology and Mining Department as Assistant Drilling Engineer.
Yeah, and your interest in EV, sir?
Sir, basically, I have started from 3 years diploma in automobile engineering.
Right.
So I want to continue in my studies in automotive engineering.
All the
Thank
very best, sir. Hopefully, you will gain much. It's going to be an overview module, this one. And then the subsequent modules will dive deep into the various technologies. Back to you, EV12.
thank you, sir.
I think EV11 is not completed.
Okay.
Thank you,
Yes,
sir.
EV11.
Yeah,
Thank you.
Thank you very much, sir.
Yes, EV11, go ahead, please.
Yeah. Good morning, sir. Myself, Saravanan. I am from Royal Enfield EV sourcing team, taking care of electrical
Yes.
proprietaries.
Okay.
So I did my engineering in electrical and electronics. So before Royal Enfield, I am part of Volvo Global Trucks, Tata Motors, and India Japan Lighting.
Very nice background. So we'll make sure that you have an idea because EV tends to be a confluence of mechanical, electrical, and software. The three big areas, to put it very simply. So it's a lot of good learning. I hope you get out of this course.
Yeah, sure.
Thank you. Yes, over to you, EV12. You've been very generous.
yes, sir. Sir, I'm Kadiravan. So
Uh-huh.
I am part of Royal Enfield team. So I have
Uh-huh.
more than 15 years experience, out of which 8 years in Royal Enfield, 6 years in ICE engine development, and last 2 years I am working in EV program, EV products. So here I am taking care of aluminum forging component, structural component. I am taking care of the mechanical parts.
Yeah.
So I'm the internal program coordinator, so that I can hear all the words of all the electronics, softwares, other things. So this course will be useful for me to learn.
Yes. Yes.
Yes, sir.
And yeah, good turnout from Royal Enfield team. Thank you so much to you.
Yeah, yeah. Thank you, sir. Thank you.
EV14. Yes, sir. EV14.
Yeah, good morning, sir. My name is Mohammed
Good morning.
Hussain. I am from the
Mohammed
same
Hussain.
Royal Enfield team from the EV vendor
Yes.
development. I'm leading the auto electrical proprietary parts, which is like
Oh, okay.
headlamp, tail lamp, wiring harness, etc. So I look forward to learn more about the EV specific components like battery packs, motor, etc. from this course.
Hmm.
In overall, I have more than 20 years of experience, and
Right.
that's it from my side, sir. Thank
Great,
you.
great experience. And definitely, the industry is evolving. So hopefully we'll help you with catching up on that.
So thank you.
Thank you. EV15, please.
Uh, Hello,
Yes, sir.
hope I'm
Yes, sir.
audible.
Yes.
Yeah. So, myself, Abu Bakr Siddiq. So, I'm from
Uh-huh.
Dindakal. So, I did my BTech
Uh-huh.
in Triple E in Bangalore. So,
Uh-huh.
currently, I'm working in a company called a Borgwarner. I have an experience of 3 years. So, 2 years in validation
Yes.
and 1 year in functional safety software development. So,
Wow.
this is all about me. I
Important
would like to,
areas.
yeah, that's why I opted for this course. So overall, I
Yeah,
wanted to
yeah.
understand the system view of this. So looking forward for this.
Yeah, you would find this particular course a little bit light on the software-defined vehicle side. I'm going to caution you on that. But I'll try to touch upon this, and I'll also alert my other faculty to make sure that we are giving you enough so that you gain. But you will definitely learn a lot about the other aspects as a complete system. Okay?
Yes, sir. That's my
All right.
objective of this course. Thank you.
Thank you. So, EB16, please. Good morning.
Yeah, hi, good morning, sir. I'm from Borgwarner, Bangalore, and I have 6 years of
Uh-huh.
experience with automobile sector. I have passion towards EV, so I opt this course, and I want to explore more info regarding EV from you, sir.
Very welcome, and we hope you meet your objectives.
Yeah,
Thank you.
thank you, sir.
EB16, please. Good morning.
EV16 is done.
Oh, I'm sorry, EB17. My apologies.
No, no problem, no
EB17.
problem.
Yes.
Hello.
Yes, sir.
Yeah, good morning, everyone. Good morning, sir. I'm
I'm
Anushka.
not able
I'm
to
from
hear you.
Baltimore.
Can you try again once more, please?
Am I audible now?
Yeah, you're audible, a little bit muffled. It's okay. I will manage. Try again.
I'm Anushka. I'm from Baltimore. I've been in Baltimore for 5 years now. I've been working in automotive domain. Um,
Oh, okay.
in this course, I
And
yeah, I'm
any
keen to learn
expectations
about
from the
the
course?
yes. I'm keen to learn about vehicle dynamics in detail in this course, especially. I've gone through the content and it's quite interesting. So I also judge for Formula One. So
Oh, nice.
I'm trying to
Formula
explore
Bharat,
that
right?
area. Yes.
Yeah, okay. Fantastic. Fantastic.
So
Welcome,
I'm
ma'am.
interested. Thank you.
Yeah, I'm sorry, your voice was muffled, so I missed a little bit of it. My apologies.
Yeah,
But
I have a poor network. That's all.
yeah, yeah, understandable. So hopefully you're able to hear me very well. Thank you so much. EV18, good morning.
Good morning, sir. My name is Meghna. I'm from Bog Warner. I
Yes.
have around 7+ years of work experience. So, initial 4 years of my career, I was associated with Active PLC. That was also an
Active.
automotive company. Yes.
Yes.
So, mostly my first 4 years of work experience was associated with body control, and then after 4 years, I switched to Borg Warner. And Borg Warner, as you know, is a company which is focused mainly on EV. So right
Mhm.
now I'm working in a platform project, and my work has mostly been towards the diagnostics and communication protocols, and mostly on the software side. So I'm planning to expand my horizons a little bit towards the power electronics side. So that is my interest towards this course. And also I did my BTech in electronics and instrumentation, and MTech in control and automation from Vellore Institute of Technology. So apart from all this, control systems has been my area of interest, and now
Wow.
I'm yeah looking forward to expand a little bit towards the power electronics side. That's the interest towards
We
my
do
side.
have a good power electronics module in this. I rate it very
Yes.
highly. And then we also have Srikantan Sridharan, who is a controls a focused person doing research, will be teaching a portion of this course also. Um, all the best to you.
Thank you.
Thank you. Good morning, EV19.
Good morning. I am Smriti.
Yes,
I work
please.
for Warner, and I also have around 12+ years of experience. I have been in automotive industry for all 12 years. I have been working for engine and gearboxes and presently working for motors and gearbox in Bogwaner. So my interest for this course is more to learn about power electronics because that is going to be part of my work when in the project in Bogwaner now.
Yeah, I think that's very, very good. Just like what I told the other person earlier. One of the things that I also would like to emphasize is there seems to be um, islands. If you really look at a motor, motor is an electromagnetic device, but it's often hampered by the thermals inside.
Yeah, yeah.
And I'll touch upon that. And also, the power electronics itself also has its own thermal issues. And how the power electronics is properly driving the motor, the sensors in the motor, all that is important.
Yeah, that is the main reason I want to learn more on the power electronics part so that I can contribute more in the projects that I'm working on.
Yeah, thermal is also important. Is my what I want to underline. Kannan Lakshmi Narayanan will be talking more about motors in the course, and he comes from industry, brilliant, and you really gain a lot from that. All the very best.
Okay, thank you, thank you.
EV20, good morning.
Hello, sir. Hope I am audible.
Yes, yes,
My name is Kiran. I'm from Maharashtra. Like
yes, Kiran.
I completed my master's in power electronics, and
Mm-hmm,
from last 3 years, I'm working in Bob Warner. I'm working in
mm-hmm,
inverter-related projects. So
mm-hmm.
basically, the idea is to know electric vehicle thoroughly. So like how system testing will happen, how software development plan will happen through this basic course. So that is my intention for this course.
Yeah, this is very, very. It's a good intro course, and if you once you go through it, you understand it very well. You pick a few areas. There are follow-up courses we offer that goes little dive deeper. Um, so what we always say this course is good to for you to learn enough and ask the right questions and be effective in managing programs, managing suppliers, managing your design teams, managing your customers. That you will get out of this. But if you want to really go do something deep, then you may want to do a follow-up course in specific areas, whether it's motors or controls or things like that, which we also have as part of the IITM code offerings. So all the best.
Yeah, thank you, sir.
My apologies, I'll be coughing here and now and then. I'm just still having some dry cough. I'll try to manage, but my apologies for that upfront. EV21, good morning.
Good morning, sir. Hope
Yes,
I'm audible.
yes.
My name is Sagar, and I'm working in Borg Warner since last 3 years. I have total 10 years of experience,
Mm-hmm.
and I'm working in software development team. My program is basically mild hybrid electric vehicle,
Uh-huh.
and my area of interest is motor controls, power electronics, and to understand electric vehicle at system level.
Very good. Very good. All the very best. Hope you gain much from this intro course. EB22, good morning.
Thank you, sir.
Yes, thank you.
Yeah. Hi, sir. Good morning.
Yes, good morning.
Yeah. Yeah. So myself, Krishna Chaitanya. I have an
Mhm.
overall experience of 6+ years in automotive industry. At the starting 3 years, I used to work on gearbox that is like PRND related. Next, I worked on ADAS related. So currently, I'm part of Borg Warner and working on inverter based projects. So my interests are to get an overview of EV, like regarding the power electronics, the motor, how it's driven, and battery management, which is also most important, and that is the main drawback in EV. So how we are overcoming this, and based upon the current market is not, it's like unstable. So how are we going forward? Like how are we passing this obstacle, and to know all about this, sir.
Very, very good. You will gain significantly, my hope, from this
Thank you, sir.
intro course. Thank you so much. Moving on to EV24. Good morning.
So, very good morning, sir. This is Alvin from HL Mando.
Oh, nice.
I'm 16 years of experience in automotive industry. Last 3.5 years, I'm working in HL Mando. I'm very interested to learn about electric mobility on future because of future
Yes.
automotive technology will going for that. So I want to learn about that. And one more thing, I want to learn improving my knowledge about EV system and battery technologies and charging infrastructure. So I want to join for this program for EV.
Very, very, very apt objectives. You hope you will gain much from this course.
Thank you,
All the
sir.
best.
Thank you, sir.
I think we missed EV5, if I'm correct. EV5?
Sir.
Yes, good morning.
Good morning, sir. This is Tanige.
Oh, okay, Tanige. Yes.
My
Yes.
ID is EV13. I named as my name. That's why.
Oh, okay. Yeah, I see that. Go ahead, Tanige.
Yeah. So, good morning to all. So, I am working with Royal Enfield. Currently, I'm leading the electronics commodity like vehicle control unit and BMS, MCU.
Oh, nice.
So I am from the vendor development side. I would like to understand more technical on these products. And
Mm-hmm.
also, I would like to understand and read something about the economics of EV. So,
Mm-hmm.
where we are, what are the trends currently? I saw your video also, it was more interesting. And
Mm-hmm.
more about like 23, there is the data which you have shared is about till 23, I
Yeah,
believe.
that's
So,
true. That's true.
yeah, so I would like to understand the current trends. So, where we are
Will
now.
do.
So, that's it, sir. Yeah.
I'll explain that. I'll explain why that happened, and I'll be going through a few slides that is more updated data. So that'll help you, and I'll share that to the group.
Thank you, sir. Yeah.
Yes, thanks, Tanigavel. EV5, I think I haven't heard from you.
EV5 done, sir. I introduced.
Yes, good morning.
No, EV5 I
Okay.
already done an introduction.
Okay, great. I think I will move on. Anybody that I missed so far?
Yes,
Okay.
sir.
Yes,
EV8.
EV8.
Yes,
Go
sir.
ahead.
Yeah. This is Vellamuthu from part of Royal Enfield team.
Mm-hmm.
I have 17 plus years of experience in the automotive field.
Mm-hmm. I'm losing you. I'm losing you. Your connection is not very good, I think.
Velamuthu, we could not able to hear you properly.
That's right. I'll do one thing. I'm going to give you an opportunity somewhere in the middle of the program, if that's okay. Okay? Oh, he dropped off also. Hopefully he'll come back. EV9, please. We covered everybody? Okay. So I'm gonna move on and get on with my introduction and then onto the course. So I'm Thiru Srinivasan. Currently, my association with IIT Madras is there's a Center of Excellence in Advanced Automotive Research. I'm the CEO. I'm not a professor by training. I've become more of a instructor because out of interest in sharing the knowledge that I've gained over the years and also in seeing the community of EV professionals grow in India, and we succeed in this as a business. So 14 years in the US after doing my master's there, and 24 years in India, and a deep engagement with China and Asia. I've seen China go from a developing economy into a very well-developed economy, and have a good understanding of how China operates and how they've been able to succeed. Bring some learnings from that to India and so on and so forth. Focus of expertise for me is in design, mobility, and sustainable technologies. And the exceptional strength that I was able to gain thanks to some very good companies I worked with how do we take an interdisciplinary project and work with industry and academia and take an innovative concept into product very rapidly? Not take 5 years for a technology to come into a product. Can we do it in 5 months? That has been my focus. And I continue to do a lot of research and focus in that area and try to bring methods to companies and startups and policy quite a bit. Like I said, IIT Madras, Ohio State University, I am Lucknow. That's my education background. See, okay. So the agenda, we'll start with an outline. We'll go with policy and market trends and sales, supply chain and cost. I know a lot of supply chain people in this cohort. Technology trends, and then recycling and circular economy. That's what I will cover. And if there is anything that you think that you need to know and we haven't covered, I will make sure that you can send me information on the forum and we will respond. And I also mentioned that the video that has been done has slightly outdated information. This industry is moving very fast. I'm supposed to have this new video recorded, but I was ill, so I'm just recovering as I still have some cough. But so my sincere apologies for that, and we will definitely share this deck to you. Okay. So on the outline, stop me anytime when you have a question, because the idea is not for me to go through it, but often I find cohorts have not gone through the videos. So I quickly rush through the videos to give an idea of what we're talking about. So why are we doing this? Why is the whole world moving towards electric vehicles? Climate impact is a very big deal, and a lot of people used to discount it, but now everybody understands that this is real. We are seeing the impact every day in different parts of the world, and it is a very serious thing. So we definitely have to deal with the emissions of CO2, CH4, and others that are altering the environment for us. Okay. And there's also a health impact, a huge amount of health impact from NOx, from the particulate matter, and the O3 that causes lung damage. And the O3 and PM and the PM particulate matter also are impacting crop yield and food security. So the whole world understands this, and people are committed, countries are committed, they're responsible to protect the overall industry. So that is what is driving the primary driver for electrification. Why does it matter? If you look at the life cycle emissions from gasoline, diesel, and natural gas, you can see that the life cycle emissions are pretty high, and they do effectively affect what is that we do to the environment. What happens in Delhi, for example, things like that. And battery electric vehicle, 2021 to 2038, with the source of energy coming from a mix of fuels, right? Even with using crude, starting with crude, and that becomes the source of energy for electric, even if you do that, the emissions are much, much lower. And significantly, you can see that the blue bar, the blue section, is the fuel electricity production is still a significant portion of the emissions. But then the rest of it is gone. It's a huge improvement. That's why EVs are there. People keep saying, oh, EVs, but you still need to use oil to make your power. Isn't that dirty? Yeah, but it's much less dirty. And then more and more renewable energy is coming into play, and that's only going to help EV become cleaner. How do you run an IC engine with renewable energy? Very difficult, huh? That's the challenge. So if you really look at a battery electric vehicle and look at the CO2 emissions, battery manufacturing is a contributor today. Vehicle manufacturing is a contributor, very similar to IC engines, but battery manufacturing is a delta addition in manufacturing. and then producing the electricity, fuel, producing there the emissions are there quite a bit, because you're converting the oil into electrical energy, and the inefficiencies and the emissions all happen at that stage, not in the tailpipe like in the IC engines. But then tailpipe emissions are zero, right? So even though looks big, these are much bigger. And then of course maintenance is much better with EVs, much less parts, and end of life, so total, it's a huge improvement. And like I said, with renewable energy, this goes away. This big thing goes away. And with the improvements, the technology improving, these things are starting to reduce. So the governments have been clamping down on a lot of things, right? So they have been saying that you need to limit the amount of emissions. Initially, BS1 came into play. They said, okay, NOx, nitrous emissions from the tailpipe should be limited to 8,000. And then the CO emissions should be limited to 4,500. That was BS1 in the year 2000. And then things cleaned up a little bit. Technology happened, cost went up, and then they came down. Then BS2 came, BS3, BS4. We skipped BS5 because we were slow and went to BS6 directly. And now BS7 is coming up. So the amount of emissions control has become dramatic compared to where we started, right? So this is what is challenging IC engine industry. And it's really creating a lot of challenges for them, and that's where the push to EVs has become much more. So what is an IC engine and what is an electric vehicle? Looking at the IC engine, you see all the typical parts. The exhaust is an interesting part that will go away with EVs. And then you have the engine sitting here. And then you have your fuel tank sitting here. Those are the critical things that get changed. Obviously, with more and more software coming in, more smarts coming in, the vehicle is changing that way also, whether it is an IC engine vehicle or EV. But we are talking about IC engine vehicle and EV comparison. So engine has 600 to 700 parts. That's a very big impact. People in supply chain, you'll realize that we remove an engine and go to motor, significant number of suppliers today are going to be stranded. Yeah, machining and other things, right? And we don't have that many parts in EV for that. So this is a very big impact. Fuel systems have about 100 parts. That's going to be dramatically going away. The battery is the fuel system in the IC engine vehicle. The exhaust system has 80 parts. That's completely gone. And transmission and drive 150 parts. That's getting simplified. So if you have a two-wheeler electric vehicle, it's only 250 components going from 1,200 components, right? So the overall supply chain becomes much simpler and different, but simpler. Assembly becomes simpler. And there are people who are saying that, hey, why can't we go the direction of the computer industry where there is a tire system manufacturer, there is a battery motor manufacturer, and we buy them, we get them delivered, and we assemble it ourselves. This is standard chassis. It's not that easy, but the reduction of parts and the complexity is making people think along those lines. Okay, so the comparative new areas are battery management system, and then there's a motor, and of course electronic control units. There are more electronics here, but honestly, IC engines also have a lot of controls nowadays. Okay, so 20 to 30 parts from 150 parts. 20 to 30 on the motor compared to 600 to 700 on the engine. Power electronics is new, 30 to 40 parts. Battery pack replaces the fuel system. So same thing on the four-wheeler. You have very similar. There's also a significant architecture change that you have to understand. With EVs, the floor is being taken up by the battery, not your fuel tank in the back or anything like that. And your frunk the front, the bonnet, the amount of material that is in the bonnet is dramatically reduced. In fact, the trend is that the whole bonnet is going to become empty because everything is going into the wheels and the axles and in the chassis. So that's a very significant architecture change. So if you are in the mechanical side of things, the architecture change of the vehicle is going to be an important criteria for you to understand and adapt yourself. There are some electric vehicle types. Battery electric vehicle is what is the majority of what we talk about EVs, like the Tesla model. So you have a big battery. That's important to understand. There's a motor, and the brakes are all using the motor also as regenerative braking. You charge the battery, and that's the charging circuit. And overall, it is much simpler, but there are some limitations like range and things like that with BEV. Because range could be limited, otherwise a battery going to be very big and expensive. People have come up with what's called a range extender, like the BMW i3 vehicle. So what happens is you do have a battery, maybe not as large as this, slightly smaller. It does all the work, but then you do have a small IC engine. The IC engine does not drive the vehicle. Its only job is to drive at an right at an optimal point and efficiently convert petrol or diesel or gas into current, into power. So it's very efficient. The emissions are much lesser because it only operates at that sweet spot and it's designed for that. So it's not a bad idea, but it just adds a little complexity. That's also an option if you want to reduce your battery cost, but still have a vehicle that is mostly clean. And of course, then there's the fuel cell. This is the hydrogen vehicle. You charge hydrogen into a hydrogen tank, and then the fuel cell will convert the energy in the hydrogen into electric. And you can have that electrical energy directly drive the motor, or you can put that into the battery and then later use it to drive the motor. So it's an electric vehicle, but the instead of the battery, the energy is being, there's a small battery here also, but the energy is being carried by hydrogen. Hydrogen is the energy carrier here. People call hydrogen a fuel. I disagree because you have to create this, which means you're putting energy into it. So it's more of a energy carrier. Then there is a plugged-in hybrid electric vehicle. So basically, you also plug in so you can charge your battery from the grid or any other source of power. And there's also an IC engine that can drive the vehicle. The difference between here and here the IC engine does not drive the vehicle. Here the IC engine also drives the vehicle. This is the common hybrid vehicles that you're starting to see now. Okay, and extremely complicated. Has the cost of the vehicle is very high because you have both the electrical and IC engine together in this. I think it's a good idea for the short term, especially for heavy vehicles, but in the long run, this will not be very attractive. So then there's a hybrid electric vehicle where you don't charge the battery. Everything is primarily through IC engine. IC engine, like the range extender, does charge the battery, but can also be used to directly drive the vehicle. So these are also fairly common. There are some other variations also, but just to tell you what everything means. Yeah. My apologies. So this has been a study done in January 2025. It's slightly updated from the other deck that you see in the videos that you may have seen. What are the customer considerations for EVs? It varies by country, right? It varies at what stage in the electrification they are. China is obviously the most ahead at this time. So the concern for environment is there, but in Germany you see even more, and in India also people are very inclined. I hope they're not lying when the surveys are being done. So it's very interesting. The concern for environment is a very big factor. Lower fuel cost is a very big factor. A lot of people say my battery is very expensive, initial purchase cost is very expensive, but running costs are really, really, really small. Um, I have a two-wheeler at home that one of my family members drive. It's an electric two-wheeler, for example. And over the whole month, the amount of money we spend on the vehicle from a charging point of view, it's about 20 rupees. It's less than a coffee per day in a day. It's 20 rupees for the whole month. That's what happens. And for some people who drive more, it could be 100 rupees. That's nothing. It's nothing. That's a major attraction. Less maintenance is a factor. You do see some good numbers, especially in India and others. Is a factor. There is less maintenance because there are less parts. Driving experience, because you get very high torque right off the bat. We'll talk about that. That's also an important factor. Increasingly, it's catching up as a big reason why people want to drive EVs. And of course, incentives are supporting. So let's talk about a two-wheeler, why a customer is interested. We know why the government is interested, why are they pushing for it, what are the customer factors, but why is a customer interested in switching over to a two-wheeler, I mean, electric two-wheeler, for example? Some of the numbers are thanks to Aether, but I'll be able to also take information inputs from you. Cost-wise, per kilometer running cost is 1/12. Of course, there are some variations. Some will be worse in terms of fuel economy, some will be better, but that's one major reason. 90% fewer parts, as you saw, so it's cheaper to maintain. Therefore, more space available because there are fewer parts. Okay, so that's what's happening. Performance-wise, fast charging is an important thing, but it is a problem. Range anxiety is a problem. Do I have enough charging everywhere? In fact, Tamil Nadu has been lagging in that, and I've been an advisor to Tamil Nadu, and there's been a lot of push to get more charging infra everywhere, including homes and whatnot. So that needs to happen. But if you have a fast charger, you can charge really fast. Torque, you get from 0 kilometers per hour, right from the start, you get 100% of the torque. That's what happens. This is an IC engine. This is how the torque generation with speed is. But with EV, you get very high torque right from the beginning. So you got to be very careful when you're driving on the roads, because people are used to seeing vehicles take some time to pick up speed and move. An electric vehicle, if you have, you would move very quickly. And other vehicles are shocked. Actually, I've seen this happen. They don't anticipate this, and sometimes it can create a problem, right? So it's a benefit, but you also have to make sure that the traffic is getting used to that. Sustainability is the main driver anyway, and a lot of people don't talk about this. Not only the emissions are less, but the heat is also emitted less. Today, when you drive on roads, especially on a two-wheeler without any mask or anything, you're actually driving through a sewer. Sewer in the sense there's a lot of bad things on the road. There is emissions from all the vehicles, there is noise, and there's a lot of heat. And if everything moves to EV, the chances are that noise is definitely going down. We talked about the dB. Heat is going down. Of course, emissions is going down. Okay, so that's another attraction for EVs. Even if electricity production in a plant is emitting some CO2, that's not emitting on the road where people are moving. On the road, there is no emissions. That's a big benefit. And of course, all the vehicles are becoming smart. So it's not just an EV benefit, but EVs are accelerating it. Total cost of ownership, I'm not going to spend time on this, but there are areas where it still does not make sense to own an EV, like buses and things like that. The total cost of ownership is still not working out. So subsidy is important. But for two-wheelers, for autos, three-wheelers, for commercial four-wheelers, it's very well understood that over the life of the vehicle, you save a ton of money with EVs. So, global shift from IC engine to electric vehicles. Germany, Japan, USA, and UK dominate the IC engine era. They have a big advantage, a lot of experience, innovation, established infrastructure. Now, with the shift to EVs and the fact that they have not really built up such dominance has leveled the playing field for India, China, everybody. And China has really taken advantage of that. They've moved to the forefront of the automotive sector. It's very possible that tomorrow, just like Japanese vehicles dominate the world, Chinese vehicles will be sold in every country in the world, including US. There's a possibility. I'm not saying for sure, but it's a very strong possibility. And that's the opportunity EVs have given. India still has an opportunity, especially in the two-wheeler, three-wheeler, and like commercial vehicle segments, but China is not focusing. The other thing that you have to keep in mind, and this is a very important chart, India, this is as of August 2024 data, India has 57 vehicles per 1,000 people. That's all we have. Of course, you don't believe it because you see so many vehicles on the road. Our roads are choked with vehicles. But a country like USA has 900 vehicles per 1,000 people. And look at the countries, Bangladesh, Nigeria, Pakistan, Indonesia, they all have more vehicles, or almost the same amount of vehicles that India does. And there are countries, of course, China is now close to 250, actually, the latest, we haven't updated that. And Turkey, Colombia, Thailand, Mexico, Brazil, Russia, Argentina, you wouldn't have expected, Malaysia, you wouldn't have expected these countries to be having more vehicles per 1,000 people, but they do. And Indians are interested in being more mobile. In a home, you may find soon 3 or 4 vehicles. The husband one, the wife one, the college-going kid one, whether it's a two-wheeler, three-wheeler, car, doesn't matter, right? There are more vehicles, more and more vehicles are going to come on the road. And that's a significant challenge, okay? So this is where the vehicle ownership is growing in urban area and rural areas are lagging, but the growth is just lagging. It's still pretty good. Okay. What are the hurdles to overcome for people to adopt EVs? What are the challenges we are facing? High initial costs of vehicle and charging equipment, particularly the battery. The battery nowadays is about 40% of the cost, used to be 50%. And therefore, subsidies and technology improvements, volume improvements are necessary to reduce cost. That's a hurdle that we need to overcome. Lack of adequate public charging options. India continues to lag in this, continues to perform poorly, especially Tamil Nadu, to some extent, Telangana, Andhra, Maharashtra. I think Karnataka is okay. Kerala is actually better. But across the country, we need a lot more charging, including at homes. At the end of the day, when you're parking, that's when you're charging the most. We definitely need more of them at home. Battery safety, capacity life, and replacement cost. This used to be a problem. It's still a problem in many people's mind. There was a period where a lot of spurious quality cells were allowed to be brought in at very, very cheap costs. You still see that in e-rickshaws in India. And that created a lot of problem where battery fires used to happen and things like that. Today, especially with people like TVS and Bajaj and others coming into the forum and field coming in, the quality controls are much better, and the government has also revised the standards. So with that, we are seeing less and less of these problems. But the consumer needs to be convinced that indeed things have improved, right? So people will buy more. We're also doing a lot of research in having a very strong battery health estimation on an ongoing basis. So that will also help. That will help with vehicle resale value and fitness approval liability, right? Battery improvements, experience with vehicles on the roads. People used to say that, okay, I have, done testing on cycling of batteries, so it'll last 5 years. But in reality, the actual use of the vehicle is not as tough as the way the tests are being done for life estimation of batteries. There have been several studies that show that even after 8 years, the battery is still close to 95% of its original health. So that's very encouraging. And resistance to change. Anytime you are bringing something new, it requires getting through this resistance. Okay? So I'm not going to spend time unless you have a question for me. These are questions for you if you had done the recording. But any questions until this point? You can raise your hand and I will call out. Yes, EV1. Go ahead, please.
So I have two questions. The first one is that the diagram which you have shown for parts for two-wheeler motorcycle and a four-wheeler cars. It's actually
Yes.
very, very thoughtful, very thoughtful. I had never seen the EV from the supply chain perspective. The number of parts and engine is come from 300 plus coming to 30 around.
Yes.
So is this, if you have, just for my knowledge, and can you share for truck or bus? Because it's a whole supply chain perspective it gives that. EV is not
Yeah,
going to
yeah.
only affect customers' profitability, but the whole
We can
supply
share
chain.
that for you. We can share that for you. It is a significant supply chain problem.
Yep.
And it's a significant problem for the government. MSMEs are really struggling already with even before the change. And so there's been a lot of evangelization that we're doing with the government to say that it's okay that we're making vehicles in India, but most of the components are still imported. And if you have to localize, you also have to take care of the fact that when you're converting to EV, there are going to be many people in the supply chain in the auto industry who are going to be left behind. And we can't do that. We have to help them transition into the EVs. There's a lot of work being done in that. It's still a lot of work needs to be done in that. But as supply chain people, as people who are designing vehicles, you need to be very aware of this. You can design anything on paper, but you need to have a supply chain that can make it. The development of supply chain is very important. Okay. Any
Fine.
other questions?
Yeah, one more question. So please share a diagram, same diagram for comparison for ICE truck or bus with a EV truck or bus.
We will. We will.
That
My
will be very
request to you
useful.
is you ask the question in the forum. So then we make sure that we don't forget and answer that.
Right. And second question I have, because as you said very rightly, for trucks and buses, the key, everybody knows OPEX is at least 20 to 30% better. But the key challenge is the entry barrier, cost barrier
Yes. Yes.
for truck and bus, which is almost twice than what the ICE vehicle is. So in the last 4 to 5 years, the battery cost per kilowatt hour almost gone down by 30-35% CAGR basis. How do you see the battery cost will go down in the next 3 to 5 years from
I'll
today
answer
on?
that. There's another
It's very
module.
important to look at the capex.
Through the flow, that's a specific question that will be answered. Good question. So it will be answered in subsequent slides.
Fine.
Yes.
Thank you so much.
So EV8 had a question. Same? Yes, sir.
So I have, I'm seeing that beyond the cost, which EV benefits will appeal most Indian customers. See, from my perspective, uh, this is not only that environmental and driver and tech. All the element is the benefit which is from the Indian side. And the second question side, no, I'm just seeing the charger honesty. Charger honesty will be a very big problem. Because
Yes.
cost point of
Yes.
view, I don't think it is a challenge because now Tata Punch available at 12 lakh. Okay, So if charger availability is even, we can do our home charges also. So I think that we can able to meet more ranges will be a good
Yeah.
opportunities in Indian market.
Yeah.
And
Agreed.
and one more point is that no, in India side, if we are towards driving in EV and localization, we will have that fossil fuel out of our foreign deficit of import, that will
Oh,
also be
yes.
benefit. Yeah, yeah, that is a
Good
good
point.
opportunity.
I should have mentioned that. Very good point.
Yeah,
But we
thank you.
do have a lot of imports today in the EV side also. We're
Uh,
importing the battery materials, cells, we're importing rare earths. So eventually, yes, you are right. But right
Yeah,
now,
I
it's
I
still,
agree. Yeah, I agree with you. But that is why I mentioned that localization is very important. But we can,
yes.
for example, power electronics components and cells and batteries, we
Yeah.
can certain time we can make our own. But compare
Yes.
with that, in fossil fuel, we cannot make our own.
Okay. Thank you so much. I'm going to keep moving. EV14 quickly, please. Yes.
Yeah, as I said, I'm from Royal Enfield.
Yes.
One question which comes to my mind every time when I say a motorcycle is the charging port. Why can't we commonize the charging port? I mean, in order to
Good
have
point.
that,
We should. We
yeah.
should. We should.
Globally,
It,
this is a problem actually. I mean, not only in India, globally for two-wheelers, cars, as well as the commercial vehicle, this is not being commonized.
yeah. Yeah. Especially for the late entrants, it's a problem. The early entrants create the mess. The late entrants have to deal with it. That's a challenge. The government is really trying, but every government in the world faces this problem. I'll touch upon this. Okay. Let me continue going, and then a lot of these questions will be answered. So, how has the world dealt with this? Um, Starting from the global, there have been many agreements, Paris agreements that have been signed, and the charging also now unifying into a common charger. All that efforts are happening. Okay, globally, that's what's happening. The automakers are saying full EVs by 2035 to 40. By that year, they want to see all only EVs. Okay, and so there's a lot of push globally. US IRA program was giving tax credits for EVs and batteries, but of the current government there is actually not for EV; they are more for ICE. So a lot of confusion in US at this time. And on the charging port, automakers are shifting to NACS. NACS is the Tesla charging port. So everybody is moving towards that because it's really elegant, compact, and so they're also, the forerunner. Europe continues to really invest heavily on EVs and push very hard. So they want to ban petrol diesel by 2035. That's definitely moving forward and happening. I can see that. And the chargers every 60 kilometers is a project that they are doing, and they're establishing several gigafactories in Europe. China is the leader in the auto industry today in many ways, and their innovations, their ability to produce vehicles at compelling cost and compelling features is very good. They had 9 million by 2023 EV sales. Charging, they already have 2.7 million public points. Amazing. Subsidies on battery R&D and rural EVs, and those are going away. Right. And the forum, EV1, the forum that I mentioned is a separate forum. It's a Google forum. Do check with our coordinators. You put that there. The comments here will evaporate after the end of the call. So I'm encouraging you to go to the forum and find out. I know this is the first module, so make sure you ask our coordinators how to access the forum and put your questions there. So coming back to this, India, of course, India had some false starts, and then FAME 2 has been the one that has had some impact. And now you have the PM e-drive. and that is also having some good impact. And India is now moving from demand side incentives to supply side incentives with PLI schemes and all that. State EV policies, different states have approached it differently, but there have been some states that have been more successful than others. Compared to China, you can see there are 2.7 million public chargers. India is at 12,000 public chargers by 2024. So we have a long way to go. And the targets, I'm not going to spend too much time on this. There are interesting targets, particularly by the European countries. Vietnam is also pushing very hard. What has India really done? There was a national electric mobility mission, and 2013 itself, nothing happened with it. Big failure. 2015, FAME 1, same thing. Nothing happened with it. Karnataka was one of the state governments to come early with an EV policy, and they have really benefited from that. Then Maharashtra, Kerala, and other states start approving EV policy by 2018. FAME 2 has actually had the most significant impact on the EV adoption, 2019 onwards. And also Tamil Nadu, Maharashtra, Uttar Pradesh, Madhya Pradesh, Delhi, they launched policies or revised their policies. And then 2023, Gujarat and Rajasthan came on board. And now in 2025, we have the PM E-Drive, which is the follow-up to FAME 2. On the charging infra, FAME 2 is still there. PLI is the manufacturing side of incentives, production-linked incentive scheme. So that is very important. You are all in the supply chain, so it's important for you to understand that. Now there is also a lot of recycling push coming in. There's a battery waste rules, EPR. The production person is responsible for ensuring that the battery comes back for recycling. So it's the OEMs, it's the battery manufacturers who are now responsible for that. Battery swapping policy came in. It's still in draft stage. I do not know if it has been released. A gentleman who's in the battery swapping industry would know better. I don't think it has been released yet, but the draft is there. State EV policies now include charging, and Ministry of Power has issued EV charging guidelines and gives some discounts for EV charging on the power rates. Vehicle scrappage policy is helping adoption because we're able to push out old vehicles and push towards EVs. Okay, other benefits that you see across the board: no license requirement for vehicles that are less than 25 kilometers per hour peak speed. Special electricity tariffs for all vehicles. Standardization. I think on the larger, higher power vehicles, CCS2 has been standardized in India, but for two-wheelers and three-wheelers, we still don't have standards. I know Ather has offered its the charging port design as a free standard that anybody could use, but I don't think standardization has happened yet. Incentives for charging infra, town planning rules. Town planning rules are still very troubled. You try to go put up a charging point in your apartment or in your community, there is still a lot of resistance to that. And GST reduction has helped. So FAME 2, we saw. Supporting policies. I'm not going to spend time on that, but just touch upon this because it's supposed to be a recap. Globally, from 2008, EVs have been launched, and now there are 14 million EVs sold. And this is 2024-25 data. And India is 1.97 million. So India is starting to accelerate on its growth. Currently, there are about 40 million EVs on the road globally. Annual sales is crossed 14 million units. EV market share globally is about 18%, and the stock, including what's on the road and what's not on the road, is about 56 million EVs. And this is the global trend, and you can see China is driving the change. And of course, Europe is also significant. US is, and we are in the other EV category. India is in the other EV along with Japan and others. So you see this acceleration that has been happening now. We call it the hockey stick uh, trend. That's definitely happening. China is really moving very fast on this. Out of the 2 million vehicles that were sold and registered in India, not including the exports that we are doing, so about 2 million, about 1.2 million of them were two-wheelers. So two-wheelers are really leading them now. Originally, the three-wheelers started, and two-wheelers are now ahead of the um, three-wheelers. And so you have about L3, the e-rickshaws, and e-rickshaws have a lot of problems. So they need to further improve in terms of design and things like that. But the sales are pretty high. And then L5 is all the auto and other type of three-wheelers. So that is starting to be significant. And four-wheelers started growing about 1.06 lakhs. But buses and others are still small in numbers. This is all data from the Vahan portal for the year 2024. If you really look at state-wise, Uttar Pradesh is having a significant portion of electrification. Most of it is all e-rickshaws. A little bit on the two-wheelers, but mostly e-rickshaws. On the other hand, Maharashtra, most of it is two-wheelers. And same thing is true for Karnataka and Tamil Nadu. Okay? And Rajasthan is a mix that way. So these are the leading states in India where the registrations of EVs are significant. So again, this is 2024-25 data. And you can see that from 23 onwards, the two-wheeler sales has almost doubled. Not quite, but almost doubled. And the e-rickshaws increased, but e-rickshaws sales is plateauing out, is what we're thinking. E-carts, very small. And then e-three-wheelers, I think has a lot of room to grow. And then four-wheelers are growing rapidly now. Buses and others are still limited. And like I said, Uttar Pradesh, Maharashtra, Karnataka, Tamil Nadu, and then Bihar is coming up. So these are the states where EV adoption is picking up big time. So India in 2024, 2 million units, we're talking about 7.7% penetration. That's 7.7% of all vehicles sold is EVs. And that's 6.2% in two-wheelers and 2.5% for four-wheelers. So it's a mix. And of course, three-wheelers are having the highest penetration. Some of the big players are Bajaj, TVS. TVS is now the leader. The latest data. Ola, Ather. Ather continues to grow strongly. Greaves and Hero with the Vida vehicles. This is all the two-wheeler market. And the e-bus market is just starting to emerge. A switch is significant, which is the Ashok Leyland, Electra, PMI, and Tatas. And three-wheelers, again, you see a very huge number, about 400 to 500 companies selling vehicles across the country. That's a significant portion. And of course, Bajaj, Piaggio, and others. Charging stations in FAME 1, we had 427 charging stations. I think there's a mistake here. There's a FAME 2 data I'm missing. I will try to get that for you. India's charging availability is really, really, really poor. We are lagging, well behind China and USA and Germany and Norway and the global average for the availability of chargers per four-wheeler. Okay, even though the numbers look good, but India is a large country, so this is the more important number. Okay, all right, I'm going to keep moving in the interest of time. So if you have questions, you can start typing them here, and I will take them up. I'm not going to let you speak out the question because just to keep things moving. So what are the technology trends, right? And that's what we work on in car quite a bit. If you start looking at from a supply chain point of view, okay, so you have the vehicle, and then these are the key components in the vehicle, particularly the electric components. There's a battery, there is a motor, and there is all the chargers and lights, and then there are some common items, right? Your frames and things like that. And if you really break them down further into L2, the level 2, so you have the cells, fuses, bus bars. On the motor, you have the windings, magnets, and laminations. Here you have the controllers, sensors, AC/DC converters. And then on the common items, you have the cooling system, the heat sinks, and things like that. Going one step further, there are raw materials. These are critical raw materials. This is what the government is now focusing on. And copper is an important critical raw material. We don't have enough copper in India. We import a lot of copper, and we even import not just ore. We import the copper in ingot form. There was one factory in India that was making those ingots that was sterilite, that was shut down because they were environmentally very irresponsible. And now there is Adani's have opened a factory in Gujarat. Hopefully, it is environmentally very good, but we need more of those. And we need to also focus on reducing copper usage because copper is going to be a very big problem in terms of cost. And then you have tin, nickel, again copper, again magnets. You have all the rare earths. There are some of the key processes that will help you in the supply chain. So now, what is a cell? A cell is, if you can imagine, there is a storage space for ions on one side. And so this is the anode side, where you have a graphene structure where the lithium ions come and stay. It takes 6 carbon atoms to capture a lithium ion. So the amount of capacity is limited because we are using graphite in the anode. So that's the limitation in terms of capacity today. On the cathode side, you have NMC cathode, you can have LFP cathode, but here's the NMC cathode. These are like shells, the way they operate, intercalation methodology. Lithium ions go and intercalate between the structure, and that's how it stores. So when you have all the ions in the cathode, it means you're completely drained. There is no energy available for use. When you charge the battery completely, now the ions move from the cathode to the anode. So then they have a higher energy capacity, and now they are fully charged. And now you can draw energy from the battery. That's the key. If the ions are in the anode, they have energy. If they are in the cathode, they have low energy. They cannot give you energy. So that's the structure. So there are particles in the cathode, for example, and the ions will have to move within the crystal structure there. And then between the particles, it moves using binders, and finally it reaches the area where the electrolyte, there's electrolyte that gives the conductivity, where the electrolyte is there. And then it goes through the electrolyte. There is a separator so that this and that does not make an electrical short circuit. You want ions to move, but you don't want electrons to move. If the electrons move through here, it's a short circuit and you may have fires. So you have a separator, and then from the separator, then it moves in through the electrolyte through the binders into the individual particle, and in the particle into the individual crystal structures that is there where it goes and sits. So everything about cell is about how these ions can move freely without getting lost, without getting into cross reactions. And if they move freely, you have low impedance. If they don't move freely, you have high impedance, and then your battery ages and it's useless at a certain point. So that's it. There are different types of structures. There's a cylindrical cell where the anode, the cathode, and the separator are all rolled into a jelly roll and inserted, and then you pour the electrolyte into it so that you have the electrolyte filling the gaps. Same thing on the prismatic structure. It's folded instead of rolled, and you have a folded structure, and so that's how you have. In a pouch, you have a layered structure, right? It doesn't go back and forth. It's just layered, one on top of the other. That's the pouch. Typically, the cylindrical cells have very good structural strength because they are cylindrical, but the pack density is low because there are gaps between the circles and they can't fill all the gaps. Thermals are also poor because of that, because there are gaps. But flexibility and availability was very good early days. But now prismatic cells have really become, people call them blade cells, prismatic cells. They become very common. So it's no longer a case that it's a big negative. But the structural strength is slightly less than cylindrical. Pack density is very, very good. Thermals are very good. And that's why most of the industry has moved to blade cells. In fact, I do expect two-wheelers and three-wheelers starting to use blade cells pretty soon because availability has improved so much. Cylindrical cells have their own problems. Pouch cells are structurally very poor because they are flexible. Pack density is okay, thermally okay, flexibility is also okay. It's easy to manufacture, so that's the challenge. Somebody was asking about cost, what direction it's going to go. Um, this, if you really look at where we are today in terms of gravimetric density, watt hours per kilograms. See, start. Okay, watt hours per kilogram is the issue. We are about roughly about 150 now. 150 watt hours per kilogram is typically what sells. And then, of course, from there you make a pack that's even lesser because the pack loses some of the energy density. So LFP is somewhere in this region and NMCs are here. So we are now looking at NMCs in the 200 to 50 watt hours per kilogram. NMCs are even better for volumetric energy density, not just the weight is even better for that. But NMCs have aging and stability issues compared to LFP, and so LFP is being preferred a lot. People talk about solid state instead of liquid electrolyte moving to solid electrolytes. It's not that easy. There's a lot of challenges there, but we expect them to come to 4, and with that, you'll see improvement on both energy density and volumetric energy density, both weight and volumetric. There is other research that's happening, lithium sulfur. There's still a lot of work to be done there. Potentially, it has very, very good reduction in weight for density. But for you, from a cost point of view and application point of view, what I want you to take away from this is majority of the cost in a battery, in a cell, is materials. If you're able to store more in the same materials, the cost of the battery will come down. Your battery will become smaller and it will come down. My prediction is in about a year and a half, the energy density of the battery will double from where it is today. Potentially, the cost of the battery will go down to 60% of where it is today. Forget about all the other things, purely from a technology point of view, right? And then there is also further cost reduction in terms of volume because more and more EVs are coming. So there's a very strong possibility that the cost of a cell will drop by 50% from where it is even today. Okay, that's a possibility. Let me see, maybe I shouldn't talk ahead. Right. Then, like I said, there are cylindrical pouch and prismatic cells. These are the components. This is the cathode materials. If you have an NMC, you have, or an LFP, you have, lithium is definitely there. Because LFP, you also have phosphorus and iron. And if it's an NMC, you have nickel, manganese. There is also aluminum variation. Cobalt is definitely there. On the anode side, you have graphite or titanium. LTO uses titanium. So from cells, you make modules, and from modules, you make packs. That's how you make a battery pack. So in these various types of chemistries, there are strengths and weaknesses. If you go to an LTO, it's one of the very earliest, it has very, very good specific energy. It means it's able to absorb energy very, very quickly. And it's able to give you a very long life. But its energy density is terrible and its cost is terrible. That's why it has not really succeeded. The price, you can see that. The performance is also a problem, but the cost is a very big problem for that, right? So its biggest strength is SP, specific power, the rate at which you can charge, not at energy density. And the safety is very, very good. It's one of the best. Like I said, price is bad and all that. And LFP is a very common material today. In LFP, you can't charge as fast as you can charge an LTO, but it's pretty good and can be improved. And its safety is pretty good. Cost is pretty good. And so that's what is driving the LFP to the forefront. NMC has its own advantages. So this is a very good spider chart for that. Then you have the battery management system. Battery management system is all about ensuring it can deliver the power when it is asked. It can charge, can allow a charge when it is, but it also has a big role in ensuring that there's a safety. So you avoid damage, avoid fires and things like that. Initial VMSs that I saw in the field in the 2015-16 timeframe were terrible. Now there are very, very good BMSs. They really manage their batteries very well. Okay. Then there are motor types. There are various types of motors. The most common one that I see today is what we call as permanent magnet synchronous motor. They typically have high efficiency. They are compact, widely used in cars. I may have another section on this to talk about the various components here, but primarily they use a permanent magnet. There are magnets that are inserted. You're not able to see it in this picture, but they are there. And then you have copper windings or what we call hairpin windings, either a regular winding, wave winding, or hairpin windings. So you have that. You have a brushless DC motor. It's simple, cost effective, but it's starting to move away. You see in two-wheelers and three-wheelers, especially hub motors, you're seeing these, but people are moving away from them for various problems. Then magnet assisted synchronous RM seems like is the future for various reasons. It uses synchronous methodology. It uses reluctance. In a magnet to generate torque, you need two things. Either you have a magnetic force that is attracting and repulsion, or a reluctance force. When two magnets face each other, it is magnetic force. When a magnet is facing an ion, the ion just gets attracted. That cannot get repelled, right? That is reluctance. So you don't have the repulsion that is working for you. It's only the attraction that's working for you in a reluctance motor. So, but with magnet assisted, you're able to make a very good motor. Then there is switched reluctance motors, which is primarily a reluctance motor. It does not have any magnets in it. So it does struggle in the low speed range. At high speeds, it's performing very, very well. And then you have axial flux motors, where in a motor, normally, as you can see here, there is a rotor inside, there is a stator on the outside, and the interface is radial, right, along the radius. Here, this is a, on this check, yeah, this is the rotor, and there's another rotor on the other side. There's a stator in the middle. So the coils are here, the magnets are on these two plates, and they face each other axially. It still rotates this way only, but they face each other axially. So there's a different way of making motors called axial flux motors. So you can have in a car, you can have one motor that's driving the rear wheel through a axle drive and differential, or you can have two such in the front and back, or you can have two motors in the back without a differential and one in the front, as the Tesla plane, or you can have a motor on every wheel. So that's also there. And here's a blow up of the motor that I mentioned. You can wind the coil with what we call as wave winding. This is very normal. This is the way normally motors are made. But increasingly, people are going to what is called hairpin winding. This is a cast copper that you insert and then you weld the other end together so that it forms a continuous coil. The benefit here is you can increase the amount of copper that goes in this space. The what we call power density increases, and it's also a little bit easier to manufacture a motor for traction motors. Traction motors use what is called distributed winding, and distributed winding is much more difficult to make. There's a lot of overhang. This extra copper that you see that is making a turn is not doing any work. Only the copper that's inside is doing the work. And in a distributed winding, this becomes humongous, huge amount of copper. And so that's people are driving more towards using this type of winding. And you see the magnets. These are the magnets that are inserted into the slots in the rotor. The rotor is on the inside. The stator is on the outside. Then there are laminated sheets that are stacked together to form the core. The reason you do that is to reduce the hysteresis loss in a motor. So if you're talking about a motor manufacturing, you need somebody who is giving you silicon steel in sheet form, somebody who can stamp that high speed and make the laminations, put that all together, and then insert the magnets on one side, on the other side, put in the coils, and then you make the assembly and you put it together as a motor. So the rare earths are necessary for making these magnets, and the copper is necessary for making this. Electrical steel is necessary for making this. And you do have an in-wheel motor where now the rotor is on the outside. So the magnets, this is a magnet, it's on the outside because that's what is rotating. The coil is on the inside, and so this does not rotate. So you have this kind of an arrangement, and this is what we call as a hub motor. Typically you see in two-wheelers. You have a motor control unit, takes energy from the battery, it takes it through capacitors, because of the way motor control unit is taking energy is not in a steady line fashion, it is in a wavy fashion. So you need a capacitor to make sure that you're able to draw current without having all this hysteresis and everything being thrown back at the battery. You don't want to disturb the battery so much. So you need a capacitor to smoothen out all these requirements. And then now the power from the battery will go to these MOSFETs through gate drivers. Gate drivers open the gates and close. These are MOSFETs. These are the most expensive part of a motor control unit. And the MOSFETs are also the biggest source of energy loss because they convert a DC current into a waveform that will drive the motor. Motor requires a waveform that creates a rotating magnetic field inside the magnet that interfaces with inside the motor that interfaces with the magnets, and that's what creates torque. So you need these MOSFETs, or you also have IGBTs that can do the work, but they emit a lot of heat that needs to be removed. So this is a typical arrangement. That's a capacitor, and these are the MOSFETs. Okay, and this is the controller. There's a lot of information that comes to the controller that controls and drives the gate driver to create the right waveform, and that drives the motor. So then you're talking about the various modules. Don't worry, this is only an introductory module, so I'm only rushing through the various aspects. There are going to be sub-modules, subsequent modules that are going to come up where people will talk about this in more detail. So what are the various controllers in the vehicle? There's a vehicle control unit, right? It takes from the driver the torque request, that's your throttle. There's also a brake request. There's also a electric machine mode request. If you really see modern vehicles, you'll see modes. You'll see economy mode, you'll see regular mode, you'll see sports mode, and like some people have named, you call them warp mode or crazy mode or whatever, where performance is what is focused on. So there are performance modes that are given. So the vehicle control unit needs to get all those inputs, and then it uses all this to drive the various um, things. So it sends a torque request to EMCS is nothing but the motor control unit. So it sends a request to this, and it also sends a torque to the stability control unit, and then the various electrical machine mode information also goes to this, and each one of them in return give feedback to the vehicle control unit, right? Look at the motor control unit. It takes the input on whatever the torque request is. It understands the status and it generates the torque and informs the vehicle control unit of it. So it's a very simplistic picturization, but these are the various control units. In a car today, there are at least 30, in some cars up to 200, 300 control units today. And all of them talk to the vehicle control unit. And people in Borg Warner, some of you may already know the complexity of this from a distributed model. We are going towards zonal model and eventually maybe a centralized model where all the controls are managed that way. That is in the software-defined vehicle vertical. We work on all those things. But this is a very simplistic model. Then there are charging solutions. There is a battery in the vehicle. There is a standard charger and an optional charger that's typically available. And so then the charger, in this case, a CHAdeMO adapter for this charger, but in India, we're using CCS2. The charger will send the power or a supercharger. So this could be an AC charger where an AC power comes and the conversion happens in a brick and then it goes into the vehicle, or in the vehicle itself, you have an AC DC converter. We call it onboard charger, so that can happen. But typically for cars, and if you go to public charging, it's all DC charging. Directly you get DC current and it goes into the battery. Obviously, there is in the BMS will have to talk to the charger control units to make sure that there is a certain right kind of protocol used to send the power. Otherwise, the battery could be damaged by too much power from the charger. There are various wall outlets and things like that. So people talked about various types of connectors. There is a CCS type 1 connector. This is a DC connector. There's also an AC connector. And then CCS type 2 is what is commonly used in India now for higher powered vehicles like cars and others. There's also AC connection in it, integrated into it. So that top part is AC connector, the bottom part is the DC type. And then there's a GB that is used mostly in China nowadays. Then there's CHAdeMO, there's Tesla. Okay, these are the various types of connectors. All right, getting into supply chain. Supply chain typically starts from raw material extraction. You will see that in the reverse, but this is really what a supply chain is. Then processing and refining, component manufacturing, battery pack. For example, on the battery side, it's a battery pack assembly. Then it goes into vehicle assembly, and then you use the vehicle, and then end of life repurposing and recycling. This is the supply chain. And most of you will start from here and look at your suppliers this way. But it's very important for you to understand the complete supply chain so you're able to understand what drives cost, availability, quality, and everything, and are able to manage. So if you look at IC engine to EV transition, there are parts of the vehicle that are not affected too much. There are parts that are affected a lot. Again, 1,400 components to 200 components. So this is the big change. So what we're really talking about, this is the size of the business, $217 billion business is what we're talking about. If you look at the ones in green, right, these are not impacted much. Body, wheels and tires, suspension, steering, interiors, lighting, climate control. They're changing with the industry. Industry is moving to LEDs and everything, all that is happening, but electrification is not really affecting them that much. That's not 100% true, There are some changes in the chassis and other things, but these parts are not changing a lot. Okay, even the tires are modified for electric vehicles because there is more torque being generated at low speeds, but those are minor changes. Okay, then now we'll talk about some change. Infotainment is changing because there's more telematics. Brakes are changing because with electric vehicles, there is more regeneration that the motors themselves can do. So the demand on the mechanical part of the brakes is less. It's a very significant opportunity. You can see a much simplified mechanical brake. It's more for safety, but the real braking happens with regeneration at the motor itself. And cooling is also reduced because you're not cooling the engine. Remember, majority of the heat generation in IC engine happens in the vehicle because much of the energy in the gasoline is not converted into mechanical. A significant portion of that becomes heat and emissions. So the amount of cooling that's required in an IC engine is much more than an EV. So in an electric vehicle, the cooling system reduces. It's still there is still cooling. You need to cool the battery. You need to cool the power electronics. You also need to cool the motor. So these areas have to be cooled. There may be other cooling requirements like AC and things that's not getting affected, right? So this is what's happening. And in the drive line, there are significant changes, right? The clutch and torque converter is removed because because you're getting torque right from the beginning, you don't need a lot of gears. Initially, the EV industry has gone without any gear changes. Even though there's a step down gear that is used for transmitting from the motor to the wheel, but there's no gear changes. But increasingly now, industry is moving towards two-stage gear. So simplified. There's a reason for that. I won't get into it right now, but that's what the industry is moving towards. Chassis, obviously, because the chassis, the way you look at the chassis, where there's a lot of stuff in the bonnet, under the bonnet, and not really under the seats. But here in the EV, the battery is occupying most of the frame under the seats, and there's very little in the under the bonnet. So that does change the chassis quite a bit. Okay. And this is an area where energy flow is completely replaced. You go from fuel and airlines to wires and connectors. Okay. And most of the time, you don't need an alternator. In propulsion, of course, motor and MCU versus engine and EMS, fuel, air system, the exhaust system completely removed. So you understand where the impact is in terms of design and supply chain. Of course, the cost is also changing rapidly. From 2024 to 2030, where do we see the change? Battery costs will drop by half from even where it is right now. Manufacturing indirect costs will continue to drop. Mechanicals will continue to drop. Electronics will optimize a little bit. Motor can also optimize a certain amount. Okay, this is true for the car industry. Same thing is happening in the two-wheeler industry. So you're going from a 9 lakh BOM to 5.9 lakhs. And here you're going from 1.3 lakhs to 0.84 lakhs. I think this number should be 0.7 now. There have been some recent developments. The cost reduction potential is even higher on the two-wheeler. So these are some of the major enablers that's enabling the cost reduction. And cell raw material cost was very interesting. There have been lithium and cobalt and nickel, they bounce around quite a bit. But what has happened recently is in 2022-23, we had a lithium scare. The price was up. But actually in 24 and 25, they are back down to the original levels. Okay. So you need to be aware of what's happening. There's a lot of geopolitics involved in this. Where are the costs for your cells, your battery? This portion is a cell. So you have the cathode that is a significant part of your cost in the cell. 63% is the cell, and out of which materials is 40% and processing is 23%. So lithium, copper, aluminum and nickel and manganese, these are the cost elements. Cobalt is a significant element, but what has happened recently is we have reduced the amount of cobalt that we are using in NMC. We went from 111 to 622 and now 811, which means 80% nickel, 10% manganese, and 10% is cobalt. So we have dramatically reduced cobalt, and then people are now working on 5% cobalt also. So on the anode side, graphite is the biggest cost. And then you also have electrolyte. It's an important element. The cost is not very high. And of course, now these are the cell labor. And when you're assembling the battery into a pack, 37% of the overall battery cost is the packing cost. And most of the costs coming from BMS. BMS is the biggest cost. Okay. If you look at supply chain for cells, starting from mining, graphite, China dominates graphite. This is what goes into the anode. And phosphorus also China is dominating in terms of finding the mined ores. And if you look at manganese, manganese thankfully is available across the world, right? Cobalt is only available in majority in Congo. Congo is mostly controlled by China nowadays. So for this particular aspect, nickel a lot comes from Indonesia, so that's a good thing, and lithium comes from around the world. But the situation changes. We look at who's processing the ore and making materials. China is a huge player. Thankfully, Indonesia is fighting back and at least processing nickel to a significant extent. And with this strength, cell component manufacturing is primarily in China, and battery manufacturing is primarily in China. That needs to be changed. The government in India is trying very hard to change that and making some progress. This is a value chain. Okay, you start with materials, you make batteries and cells, you apply them, you reuse them or recycle them, and then you take it back into primary materials. Some of the large players in this game are listed here. And when I share this with you, kindly investigate that and give us feedback. So now moving on to the motor. The motor supply chain is also same thing: raw materials, material processing, component manufacturing, motor assembly, testing and quality control, integrating into vehicles, and then distribution aftermarket. And we should really have recycling there added to it. As far as the BOM cost is concerned in the motor, and this number varies, magnets cost 32% of the motors. And when China shut down supply, this cost went up to 50, 60%. In some cases, you won't even get the material no matter how much money you're willing to pay. So magnets are the most important element in a motor. The second most important element is copper, right? So copper, now the prices are going up. So this pie in the this slice in the pie is growing, unfortunately. So then there are other components. Then there are sealing components. This is the assembly process of assembling the motor that's happening. So magnets we are importing. Stack electrical steel localization is happening. Copper, we must reduce copper usage. It's a very big cost issue. And of course, housing is usually is aluminum. So in the rare earths, I said there's rare earth mining, rare earth element separation, element processing, magnet manufacturing, and then you build that into motors. So if you look at mining, getting the oxide out, China dominates in a big way. And India is starting to grow. This number is growing rapidly. This 2% should be going to 10% pretty quickly. And refining and processing, again, China dominates, and magnet manufacturing, China dominates. Okay. Let me take a pause. So if you type some questions, I can answer them. Yeah, EB1 asks a question. Do the trends align as expected? Pretty much. The only negative that has happened is the US government support has waned. And so that is affecting. The trends are still pretty good. 2030 is a very significant benchmark, and what we predicted will happen according to the plan. China is actually accelerating ahead, but US is slowing down, so they're kind of balancing out each other. Charging infra for CVs, trucks, and buses. Yes, we'll share that. Like I said in the group. Okay, hydrogen. Yeah, I didn't want to get into it. I just wanted to introduce the hydrogen here. But since the question came up, see, hydrogen is a carrier. Hydrogen doesn't naturally occur in nature, at least on Earth, not much by a significant measure. So what you need to do is you need to create hydrogen, either from methane or from some other organic source or water. Water is the biggest source. So you split water into hydrogen and oxygen. So okay, so that is how you create hydrogen. So you put a lot of energy to do this hydrolysis. Okay, and let's say you put in 100 units of energy there. By the time you take that hydrogen, you transport that, you compress it, you refrigerate it, you transport that, and you bring it to the vehicle, you load it into the vehicle, and it's still under compression in the vehicle. And from there, the hydrogen in a fuel cell gets converted into electrical energy, and hydrogen becomes water, and it gets emitted as water vapor and water, which is nice. But now you convert that into electrical energy, and then you use electrical energy to drive the motor and get mechanical power. You start with 100, you end up with less than 10 at the wheel. And similarly, on a similar comparison, you start with 100 with the diesel or petrol, you will end up with 16 at the wheel. So hydrogen is energy inefficient, number one. That's a big issue. And also, compressing and carrying hydrogen is difficult because hydrogen is the smallest molecule. Containing that in any material is very difficult. It requires special material, and you also have to compress hydrogen because it's a gas. It does not have a lot of density. So if you want to carry enough hydrogen, you have to compress it. There's a lot of challenges there. It does make sense in some cases, like in very heavy trucks and things like that, because you can charge it very quickly. The speed of charging is very good compared to battery. But energy-wise, difficulty-wise, hydrogen is more difficult than battery. That's at least my opinion. If somebody can correct me, I'm willing to be corrected. That is it. Um, the uh, the other aspect is the development of fuel cells and electrolyzers is still at a fairly earlier stage compared to the battery. Battery has achieved a lot of development progress. What are all the new initiatives done by Indian government from 2025 to next 5 years? I think the focus is more on critical materials like motors, cell manufacturing, electronics manufacturing, power electronics manufacturing. The incentives are going to move towards that. They're going to move away from OEMs to tier one and tier two companies. That's where the incentives are moving. There's a lot of focus on imported materials like rare earths, copper, lithium, and things like that. That's where the focus is. You may not see subsidies coming for long anymore on the demand side. When somebody buys a vehicle, they will get a subsidy. That may go away pretty soon. There's a lot of subsidies and support on the manufacturing side that will gradually move from OEMs to tier one and tier two so that we are able to manufacture much of it locally here. That's where I see the trend. Um, Chassis lightweight is a challenge. Yeah, see, Lightweighting is common to IC engines and EVs. You need to lightweight. Um, Interestingly, um, whether it's fuel or battery or hydrogen, you end up carrying the fuel, and some of the fuel is used to just carry itself, right? So you need to definitely reduce the weight of the battery and reduce the weight of the fuel tanks, hydrogen tanks, and all that. You also have to be able to improve the efficiency. The motor efficiency, the complete system efficiency also has to improve so that your fuel consumption per kilometer reduces. Similarly, kilowatt hour consumption per kilometer reduces. Um, there's still a lot of opportunity. I predict that we can reduce it by 50%, which means you have double the range on the same battery and things like that. And we're also working on speeding up the charging speed. We talked about improving the energy density of batteries. If you can charge a vehicle very fast in 5 minutes, then you don't need 1,000 kilometer range on your vehicle. A 500 kilometer range is more than enough, just like what you have in your petrol vehicles today. So that is also another factor. We expect the safe charging speed of batteries go up by 3 times in about 2 years. So much research is happening, so much is progressing at the TRL level, technology readiness level, to 5, 6, 7. When they hit 8, they're going to be seen in products. So I think in about a 2-year period, you will see that you'll be charging your vehicles 3 times faster, effortlessly, safely. Okay, so all that changes will help. How can we overcome? Yes. So lightweighting should be pursued no matter what, whether you are with IC or everything. There's still a lot of opportunity. Okay. So coming back to recycling and circular economy is very important. The environmental impact is there. Manufacturing lithium and rare earths and copper is impacting the environment very badly. In fact, China has trashed a whole section of its country in Inner Mongolia to manufacture rare earths. That place is hell. Obviously, it's giving them a strength, but this is definitely an issue. So, trying to get material from Earth is difficult. And that is especially true with rare earths. That's why they're called rare. Actually, rare earths are not really that rare. It is just that they're not available in agglomerations. Like if you want to find gold, when there is gold, you can pick enough gold as agglomerations, and then you just need to process it. But with rare earths, if you take a thousand quantity of material and you try to extract rare earths from that, you get less than 1%, less than one unit of it. So that is the difficulty, and it requires very, very heavy hard chemicals to extract them. So there's a lot of research going on how we can extract them without using bad chemicals and so on and so forth. Good progress is being made on that. But rare earths are essential, but they are very difficult to process. Most processes are, whether it is iron and steel and copper, they are, but rare earths are even worse. And we'll see how this goes. And so that's why recycling is very important. Recycling is much, much better for the environment than taking primary materials from ores. So government initiatives in India, there's a draft waste management rule that was brought up in February 2020. It's not implemented yet, but it will get implemented. And it will become the responsibility of all manufacturers to manage their materials. Even if consumers are using it, ensuring the consumers returned at the end of life becomes a responsibility of the manufacturers. So that's coming. It's already there in Europe. And then Mission Life was launched in November 2021, very much on the same areas. And then battery waste management rules were brought up in 2022. And there is further incentives that have been brought up and amended and everything. And now we have a critical minerals mission that has been launched. The government is doing its level best. If you look at consumers, people who are saying who should be responsible. In Japan, car manufacturers are expected to be responsible for that, followed up by battery manufacturer. And then if you really look at on the other extreme, China, 7% put it on the car manufacturer, 23% on the battery manufacturer, and 13% on the 23% on the vehicle dealer, 13% on battery manufacturer, and 26% on the vehicle dealer and such systems. And that is the trend. So people are now trying to ascertain who's the right person to be responsible for ensuring that the batteries are recycled. One of the important things in recycling is, how much cost does it cost to collect and recycle, and how much do you recover? So if you look at the assembly cost of various battery packs, right? The costs are significantly different. This is the pack of module level, module cell level. That's the cost that you see. Now you take that, right? It's about $120 per kilowatt hour at the vehicle level. Once it's implemented, that's the cost of the battery in the vehicle, not the cell cost. Cell cost is lower, but then you do a pack and then you integrate that in the vehicle. This is the cost that you get. With cars, it's slightly more, $140 per kilowatt hour. Buses and trucks, it's slightly more, right? So there's a lot of scrap that is available at the production level itself, right? And the productions are improving, and we expect the production scrap to be smaller by 2040. But end of life lithium-ion battery scrap is going to be significant. Typically, how do you do mining, refining, produce cell materials, produce packs, use it for the first life, first time that material is used in a cell, in a vehicle. And then at the end of life, there are applications where the same product can be used when the amount of current draw is much less. You can still use those batteries that are used in a vehicle in your home backup storage or things like that. You use a UPS at home, right? You can do that. It's called second life. And at the end of second life, again, you collect them and hopefully we don't do disposal in a landfill. That would be bad. You take it and you recycle it, where you dismantle, pre-treatment, metal recovery, and in every stage of this process also you get some scrap. Take all that, you refine, and you get materials. So this is what happens. In recycling of batteries, there are two significant processes: hydrometallurgical process and pyrometallurgical. Pyrometallurgical, as the name suggests, you actually burn the cells in a controlled environment and you use a lot of energy. Lithium and manganese burn away, but you recover cobalt and other materials. So it's not very efficient. So people have now moved towards hydrometallurgical process, where just it says hydro, it uses a lot of harsh chemicals to do this. Very high recovery rate, high purity, low energy consumption. But you get a lot of wastewater because this is hydrometallurgical. Slightly longer process, takes more time. Wastewater treatment must be implemented. So this is the amount of recoverable value in various chemistries of batteries. Obviously, NCM 111 has a lot of cobalt, and cobalt is highly valued, and nickel. And NCM 622 has more nickel. So now we are at NCM 811 and NCA. Here, the amount of recoverable value has reduced, and LFP has much less. It's primarily lithium that you're recovering. That's important to understand. So the large-scale recycling margins are turning out to be 15%. You collect batteries at $25 per kilowatt hour. This is the end of life. Remember, the original cost of the battery is $140 per kilowatt hour when you put it into the vehicle. At the end of life, today you can get $25 per kilowatt hour. You give it for recycling, and then there is a huge amount um, of acquisition, transportation, labor, and all that, and everything eats into it, and then you end up making $4 per kilowatt hour at the end of the day in recycling. So there's a lot of work going on in improving this. It costs a lot of money to to set up a recycling plant. The indirect costs are big, engineering and things, building the facility, and direct costs on the infrastructure is also very high. But that's a one-time cost. What's more important is the operational cost. The reagents and consumables are very big. This is the chemical that you're using. That is very, very big and takes a lot of energy. So utilities are very big. And labor, there's a lot of labor in dismantling the batteries and bringing them back. And maintenance is a small portion, and general administration is also there. Recycling scope in India, evolving battery technology is a problem, right? Today I get one type of battery, tomorrow I get another type of battery. I need to learn before I can open it and recycle it. It's a major issue. There's no standardization today. And with the technology evolving, it's hard to standardize. So that's a problem. Battery material price and high recycling cost. The recycling cost is very high, but what you get out of it at the end of the day, what people are willing to pay is smaller. So that's an issue. Okay. Battery pack design. Battery packs are not designed for recycling. In fact, most battery packs are designed so that they don't disintegrate, they're thermally very good and things like that. But the flip side of that is you're not able to easily dismantle the battery and take things out. There are batteries that are completely filled with epoxy for various reasons. There's nothing you can do about it other than burning it, unfortunately. The last item is also very important. Remember, batteries are stores of energy. They're like a bomb. They have energy in it. And when batteries reach the end of life, they're even worse because now their behavior is not very easily predictable because they're end of life. So you have to completely drain it, handle it very carefully, and so it adds to handling and transportation cost. Recycling opportunity is new opportunity. There's a lot of opportunity for new recyclers to enter and succeed in this. There's a fragmented market, so if you can come up with a consolidation, it's going to be very good. So partnerships are very important in recycling, and strategic collaborations are very important. We do advise a lot of recycling companies. Right. Okay. I think I just finished this. I hope it was useful. Um, Let me see if there are any questions I can quickly answer. Lithium sulfide battery technology evolvement now. I think the challenge is not only in India, across the world, is sulfur itself gets lost. And there's a lot of cross reactions that happen. The stability is the problem. Still, I would say that lithium sulfur is at a technology readiness level 4 at this time. Maybe you can argue it to be 5. There's still a lot of work for it to get to TRL 8. And there is also the sodium ion technology that's coming up. Its cost advantage is so good. Even though lithium sulfide may be better, would it make economic sense? There's a lot of research going on it. I would say maybe 3 years before you would see practical application in a vehicle abroad. Maybe 5 years before it will happen in India. Okay, I will take 2 more questions because we are out of time. I don't want to hold you for too long. You can put your hand up. Yes, sir. EV22.
Yeah, sir. So as you mentioned regarding China is a globally head
Yeah.
in all these things regarding the even the manufacturing from raw materials to the product. As we
Yes.
see, some of the countries are even buying the cars. So compared to the other industries, so as China is evolving, so what would be the market here? Because the costs compared to other companies and BYDs are, there's a difference in the range providing by them. What would be the future on this? Like,
This could be controversial, but I'm not trying to be controversial. I'm trying to say it from a reality point of view. Just like India opened the door to leading companies from South Korea, Hyundai, from US, Ford, GM, from Europe, right? Volkswagen, Renault, Nissan. Um, I think we should not hesitate to open our doors to China. China is the market leader, technology leader in this business. Um, Geopolitically, we may have our differences with China. We may even be in somewhat enemies in things like that. That's a different issue altogether. Setting that aside, just to make a point, I think we need to work with China, and rather than try to reinvent the wheel, try to find an opportunity to get ahead of them. What I advise from Center for Advanced Automotive Research is Chinese are dominating this business for many reasons, but the most strong point is in the batteries. They are very good on the battery side. They really built a lot of advantages of that. There is still opportunity for India on power electronics and on software driven vehicle side and on the motors. Um, Today, motors rated torque is 50% of its peak torque. The only reason is because the motors thermals are terrible, right? And that is even after using dysprosium that is only available in China to make rare earths. India has rare earth materials available in India. We are trying to make them, but we still need dysprosium coming from China for improving the coercivity, which is the resistance of a magnet to demagnetize, is called coercivity. To improve coercivity at high temperatures, we need that. Even with that, we are 50%. Anything above 50% rated torque you run for long enough, you will heat up and you will have problems with magnets and everything else, even with this process. So can we redesign the motor that is thermally better? Can we redesign the magnet manufacturing so that even without dysprosium, we have uh, good coercivity? We are working with ARCA in accomplishing that. A pilot facility has already been established, and we have demonstrated that this works. Samples are being tested by all OEMs right now. There is possibility of somebody investing in this and scaling this up. This is completely developed with the Indo-Japanese cooperation. Uh, China does not have this technology, so this would be great. But we need to improve the efficiency and the thermals of the motors. That will give India the opportunity to forge ahead. Okay, that's an opportunity. Um, but we should not shut the door to China. If BYD vehicles are good, let's bring them in. Let's encourage them to make assemble them in India. Let's get us all put our hands on it, drive it, and learn from it, and do something better than them. But if you shut the door, then you're going to only have poor quality vehicles being sold in India. Like we had Ambassador for years. It was a very old technology. When Maruti came, everything opened up, and we have better cars, pretty close to world class cars. That's what we need to do. The industry will learn and adapt, but we should not shun China, in my opinion.
okay, sir. Yeah, thank you.
Anybody else? Thank you, everybody. You have been very kind in staying a little longer, and I hope I've been able to give you some insights. This is just the first module that gives an overview. This is supposed to be an overview. I'm sure you have a million questions, and a lot of this is still new to you, but you know what is what. and you can start from here. This particular deck I will share. This is an updated deck compared to what you saw in the videos. So have this also by your side, and wish you well. Thank you. Thank you, everybody.
Thank you, sir.
Thank you.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.